Hello everyone, welcome back. So this time we are looking at a few examples from chapter 6. Now, we've learned some new equations in this one. We have our equilibrium equations, but then we also have our friction equations. But those friction equations, they are a bit tricky in the fact that our frictional force, we only actually know what it is if there's a special circumstance. That's where if we were to apply a greater load or a less load, movement would impend. Okay, so I mean, like, it would begin if we were to apply just a bit more or a bit less force. And in those cases, my frictional force is going to be equal to my coefficient of static friction times the normal force. Now, in this case, for these examples, I'm going to say that my coefficient of static friction is 0.4. Now, this is only the equation I get to use if I'm in a situation called impending motion. It means that if I add any more force or any less force, it's going to start moving. Okay, so let's try this out. So my force equals this. Now let's look at the first case where I have just a block and I'm pulling on it in a perfectly horizontal direction. So I draw my free body diagram. I have my weight going down, that's 400. I have my normal force pointing up. I have my load pointing right. And I have some sort of friction pointing in the opposite direction. And what I know is that at this point, motion is about to impend, which means that if I add any more force, I will begin to move. So instead of having my frictional force be an F, I'm going to actually change it to the little equation here. Now if I look at this, I've got two unknowns and I get two equations. So it's fairly simple. So I'll do some of the forces in the Y first. That's going to be equal to my normal force minus 400. And therefore, my normal force will equal 400 pounds. Then I'll do some of the forces in the X direction. And what I'll get is that I have P minus 0.4 times my normal force, which is 400 pounds. And that means that P is going to be equal to 160 pounds. So if I apply anything greater than 160 pounds, I will begin to move. Anything before that will not cause it to move. Okay. Fantastic. Now let's try out this second situation. Once again, motion is about to impend if I increase the load at all. Sorry, motion is impending, which means if I increase the load at all, it's going to move. Now let's try it out. So first off, my load is at an angle this time. So that's P, and it's got a 30-degree angle. I have my weight coming down, which is 400. I have my normal force pushing back up, and I have my frictional force. Now, since motion is impending, once again, my frictional force can be replaced with this equation. If I do that, everything is pretty simple to solve for. So I'll first do some of the forces in the Y direction because in the Y direction I have, let's see, I actually have two unknowns. Oh no, algebra. Oh, this is, painful. But that's life, everyone. That's life. Okay. So some of the forces in the Y direction, and I get normal force pointing up minus 400 minus the vertical component of P, which is going to be P sine of 60. So that'll be minus P sine of 60 degrees. It's all equal to 0. And my sum of the forces in the X direction is going to be equal to P cosine of 30 minus the coefficient of friction times the normal force, which I do not know. So I have two equations, two unknowns, and if I solve for it, I really don't care about the normal force. It's not actually important for this. I'll get that my load is going to be equal to 240 pounds. So because it's pressing at an angle, and because that angle is actually causing more friction, it's going to take more force to get it to move. Okay, so with that, we have solved this problem. We figured out what the load is in either case, to cause motion. If I go anything above this, it'll cause motion. So thank you for listening, and I'll see you all next time. Bye-bye.